Section 4.7 deals with point-slope form of a linear equation. 4.7 is broken into two sections because it is very, very important. So we've got 5 warm-up problems that we need to start with. The first 3 ask to find the slope of the line containing each pair of points. So for these 3 problems, we need to use our slope formula, which would be m equals y2 minus y1 over x2 minus x1. Please make sure that you label your ordered pairs: x of my first, y of my first, x of my second, y of my second, so that you're able to very easily substitute into your formula. In numbers 4 and 5, we're asked to write the following equations in slope-intercept form, which means get y by itself. Okay, so slope-intercept form is y equals mx plus b. So we solve for y. Okay, so let's take a minute here to check your answers. Number 1, the slope should be positive 2/3. Number 2, the slope is -1, because in that denominator we have 4 minus -2, which turns into 4 plus 2, giving us a positive 6 on the bottom with a -6 on top. Number 3, the slope simplifies to -2. 4 and 5, if we are writing these equations in slope-intercept form, first of all, in number 4, there's parentheses there. So to get rid of the parentheses, we distribute. So we have y minus 5 equals 3x plus 6. To then get y completely by itself, we need to get rid of that minus 5 by adding 5 to both sides. Notice how I put the plus 5 underneath that positive 6 on the right-hand side when I added it, because those are like terms and can go together. So we end up with y equals 3x plus 11. And in number 5, we just needed to move all of the other terms away from the y. So I started by moving the 3x, subtracting 3x from both sides. I then got rid of the plus 20, subtract 20 from both sides. Notice the right side now becomes negative 3x minus 20. They're not like terms, so they become neighbors, keeping their appropriate signs. We then get y completely by itself by dividing both sides by 4. And when we divide this negative 3x minus 20 by 4, the negative 3x is getting divided by 4 to give us negative 3/4 x, and the negative 20 is being divided by 4 to give us a minus 5. All right, so our goals for this part of the lesson is to be able to graph a line and write a linear equation using point-slope form. We're also eventually going to be able to write a linear equation given 2 points in slope-intercept form and in standard form. Okay, so on our reference sheet, that laminated paper that you received at the beginning of the year, we have all 3 forms of our linear equations. So our previous lesson dealt with slope-intercept, and now this lesson is going to be point-slope form. Now, point-slope form of a linear equation, because math people are not very creative, it includes a point and a slope. Slope-intercept included a slope and the y-intercept. Okay, so point-slope form, the slope is going to be continuously represented by m, and then the point that we are referring to is this x sub 1 and y sub 1. So it's just going to be a basic ordered pair. And notice where these pieces of information go in our point-slope form of an equation. So the point-slope form, it will have the y built in. It will have the x, the first x inside the parentheses built in addition to the minus signs. Then the y from our ordered pair goes here. The m, the slope, goes in front of the parentheses on the other side of the equal sign, and the x from our ordered pair goes in the back part of our parentheses. So we would say y minus y1 equals m times x minus x1. Okay, where slope is m and our ordered pair is x1, y1. So here we have a model that says to write an equation in point-slope form for the line with the given slope that contains the given point. So our slope is 1/6, so it's going to go in the m slot. Our ordered pair is 5, 1. So this is x sub 1, y sub 1, so just our x and our y. So when we substitute in, okay, the y minus is going to be there automatically. The x minus will automatically be there. We're substituting for m, x1, and y1. So when we substitute in, it looks like the answer isn't even written here. Our final answer will say y minus our y1 is this 1 from the ordered pair equals m, which is our 1/6, times x minus our x sub 1 from the ordered pair, which is 5. Okay, so the pieces that we are plugging in are going to be slope, x1, y1 from the ordered pair. So our first 4 examples, we are going to do just this. We're going to write an equation in point-slope form. Okay, so I'm going to start off, I'm going to literally write my y minus y1 equals m times x minus x1. So there's my point-slope formula as written up here and also on your reference sheet. So the 3 pieces that I'm going to be plugging in are slope in the m spot, the x of our ordered pair, the x of our point, back in x sub 1, and the y of my ordered pair in the y sub 1 spot. So I'm going to label my pieces of information here. So I've got a slope of -4, so that's going to be m. And I've got an ordered pair 0, -3, so that's an x and a y. So this is x sub 1 and y sub 1. So these 3 values are going in the highlighted spots. So our point slope form of our linear equation here is going to say y minus y1 is -3 equals m is -4 times our quantity x minus x sub 1 is 0. Now, there is one thing that we do need to fix here. Okay, we have it in point slope form and we want to leave it in this form. Okay, however, I do have 2 negatives here right next to each other. So this needs to be fixed and we need to write our final answer as y plus 3 equals -4 times x minus 0. In our second problem, we have a slope of +1. We have an ordered pair, -1, -4. So we're going to label slope as m. We're going to label our ordered pair. -1 is x of our one and only ordered pair. -4 is y of our one and only ordered pair, so x sub 1 and y sub 1. M, x1, and y1 are going into our highlighted pieces of our formula. So the formula says y minus y1. So we've got y minus y1 is -4. So we've got a double negative here again. Equals m, which is 1, times x minus x1. So x minus my x sub 1 is -1. So we've got 2 double negatives that need to be fixed here. So this y minus -4 is going to turn into y plus 4. X minus -1 will turn into x plus 1. So our final result here is going to be y plus 4 equals 1 times the quantity x plus 1. Now the one outside the parentheses that represents the slope, we're leaving it there for now. However, if there was no number there, the implication would be that it's a 1. So in higher levels, you're not even going to see anything there, and it's implied that the slope is 1. But we're going to clearly show our slope and our ordered pair within our point slope form right now. Okay, number 3 says our slope is 2, our ordered pair is 1/2, comma 1. So 2 is our m, 1/2 is x sub 1, 1 is y sub 1. So plugging into our formula for our highlighted pieces, y minus y sub 1 is 1 equals m, which is 2, times x minus x1 is 1/2. Nothing that needs to be fixed there. We don't have any double negatives. And our last one before we go ahead and start graphing, number 4 says slope of 0, ordered pair 3, -4. So slope is 0, so that's m, 3 is x sub 1, -4 is y sub 1. Plugging into our slope formula, y minus y sub 1, so y minus -4 equals m, which is 0, times x minus x sub 1, which is 3. One thing definitely has to happen here. 2 negatives need to come together to give us a positive. So we have y plus 4 equals 0 times x minus 3. Now, because this particular problem, the instructions specifically say to write it in point slope form, this is point slope form. However, point slope form is not the most logical option here due to the fact that this says y plus 4 equals 0 times this quantity. So that means all of this stuff on the right-hand side just goes away. So we actually have y plus 4 equals 0. So this equation would make more sense to just write as a y equals. So we would subtract 4 from both sides to write it as y equals -4. Okay, so that would technically be a horizontal line. But again, we're just explicitly following these instructions. All right. So we've got 5 problems remaining dealing with graphing. So you'll see that in each of these example problems, we have equations that are written in point slope form. What we need to do is we need to first identify what the point was. So we're basically backtracking, doing the opposite of what we did in the last 4 problems. So we're going to identify the point, plot the point, and then identify the slope and use the slope to plot additional points. Okay, so let's take a look at number 5. So actually step 1 says to identify the point and the slope right away. So, all right, so number 5. The easy thing to find here is going to be the slope. The slope is right in front of my parentheses, okay, on the right-hand side in front of the x. So my slope is 2, which we want to write as a fraction, 2 over 1. So rise and run. Now, because of our formula, okay, the formula says y minus y1 equals m times x minus x1. These negatives, okay, actually give us our point here opposite of what it is. And what I mean by that, the number with the y is going to be the y coordinate of our ordered pair, and the number with the x is going to be the x coordinate of the ordered pair. But based on the formula, we made it the opposite, so we need to undo that opposite. Meaning my point, I'll use red here, my point is the ordered pair, the x coordinate, the number with the x is -3, but we need the opposite of it, so it's going to be +3 for the x. And then the number with the y is -1, but we need the opposite of it because these negatives in the formula, so we need +1 for the y. Okay, so we just pulled out the point and we pulled out the slope from this equation, and now we're going to start by plotting the point. So we're going to go to 3, 1. So right 1, 2, 3, up 1. And now we're going to use our slope of positive 2 over 1 to plot additional points. So we're going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. We can also go back to that initial starting point and go opposite in both directions. So we're going to go down to left 1, down to left 1, down to left 1. I see some of us are doing a really nice job plotting a lot of points. Others are just drawing a random line. We need this specific red point here for our starting position. And then we need all these additional blue points that's telling us where we're going with our line. It gives us the exact slope that we need. Okay, so I want to make a line, not a rectangle. So here is my line. We need to use a straight edge to connect those points and put arrows on the end of each side of the line to show that it continues indefinitely. Okay, next up, let's see, I don't want to do all of these problems. Let's do, we'll do number 6, I guess. Number 6 says y minus 4 equals 3/4 times x plus 2. So first we want to identify our point and our slope because this is in point slope form. So our slope is the number in front of the parentheses, which is 3/4. So m equals 3 over 4. And we're going to write rise over run. All right, now the point. The number with the x is the x coordinate, the number with the y is the y coordinate, but we need the opposite of both because of how our formula worked. So number with the x is 2, opposite of 2 is negative 2. Number with the y is negative 4, opposite of negative 4 is positive 4. Okay, so we identified our point and our slope. We're going to plot the point, so we're going negative 2, positive 1, 2, 3, 4. Let me get my thicker plotting pen. Negative 2, 1, 2, 3, 4. Okay, and now we're going to use that slope of 3 over 4. We're going to rise 1, 2, 3, run 1, 2, 3, 4. Rise 1, 2, 3, run 1, 2, 3, 4. We can go back to our starting point, the red point, go opposite in both, so down 3, 1, 2, 3, left 4, 1, 2, 3, 4. Down 3, left 4. And then we draw our line, going through those points. And we put our arrows on the end, showing that it does continue on and on forever. Okay, I'm going to do 2 more problems with you, and you'll do one independently. So number 7. Number 7 is somewhat similar to number 4, okay, in that there is a slope of 0. So we can do a couple things. We could just leave it as is and say, okay, well, the slope is 0. Well, let's write that. M equals 0. Our point, number with the x is negative 4, take the opposite of it. So positive 4. Number with the y is 3, opposite of it is negative 3. So 4, negative 3 is our point. So if I start there, I go to right 4, down 3. There's my starting point. Now if my slope is 0, what type of line is that? Well, if we're not sure, we can write it as 0 over 1. And if we put our rise and run, It means we're not rising, but we're running. So that's going to be a horizontal line. Okay, so we are drawing a horizontal line that goes through our point 4, -3. Okay, and it continues on in both directions. Okay, we could also say, well, let's rewrite this because that whole right side of this equation is 0. So we could write this as y plus 3 equals 0. Subtract 3 from both sides to get y alone, so y equals -3. And you'd be like, okay, well, it goes through -3 at y, so y is -3 right here, and there's no slope. Slope is 0, boom, horizontal line. So any y equals a number is a horizontal line. So if there's only a y, horizontal line. All right, we'll do number 8 together, and then you will do number 9 on your own. So number 8, we have y plus 2 equals the opposite of the quantity x minus 2. Now, the invisible number in front of this parenthesis, there's a negative there, but it's an invisible -1, which means we can write our slope as -1, which would be -1 over 1 when written as a fraction. So write our rise over run. Now for our point, the number with the x is -2, but we need the opposite. So +2 is our x. For y, we're going to need -2. So we start with our point of +2, -2. And now we're going to use our slope of -1 over 1. Remember, whenever you have a negative slope, you put the negative sign either with the top or the bottom so that you move negative in only one direction. Okay, because again, 2 negatives make a positive. So if you move negative in both directions, you're actually going to have a positive slope. So if I rise -1, it would mean I start at my red point here, my starting position. I'm going to go down 1. Run of +1 means right 1. So down 1, right 1. Down 1, right 1. We could also go backwards, go back to that starting point, go up 1, left 1, up 1, left 1. And then we can draw our line using our straight edge and showing that our line does continue on forever. Okay, so your only task yet to complete this part of section 4.7 is to graph number 9 using examples 5, 6, 7, and 8, not really 7, but 5, 6, and 8 as your models. So we need to identify our slope, write it as a fraction, show our rise over run. Identify our point, remembering that because of our formula, we need to take the opposite of the x and the opposite of the y. Okay, and the number with the x is our x coordinate, the number with the y is the y coordinate. So we then start by plotting our point and use your rise over run to finish plotting additional points and draw your line.